Starting lesson 7.1, and you should have a figure like this on your notes. And basically what I want to go over with you is how to classify and draw three-dimensional figures. So first we kind of have to take a look at our picture here, and we need to decide for ourselves, okay, what are we going to call each of these things? Now you should have 5 boxes with different names. So the first thing we need to label on our prism is this is going to be our base. And as I mentioned, it is a prism. Okay. That just means that it's kind of like a three-dimensional figure. All right, the next thing we need to know is our height, and that's obviously going to be this thing here. How tall is our figure? We already know that, so that's not a big deal. So this is our height, all right, on our three-dimensional figures. The next thing we need to look at then is what we call a face. And now it's not like the face of our face, but shapes have faces too. Now, if I held up a three-dimensional object, all right, you would say, like my book, you would say that this is the front cover of the book, all right? And this would be the front, and then this is distinctly the back. Well, how do we know? Well, this says the name on it on the front. Shapes are like that too, and we need to specify that as well. So if I were to look at it, this shaded side, okay, if this was a three-dimensional figure, okay, would be what we call a face, all right? So it's one of the sides of our three-dimensional figure. Finally, we have, or second to last, we have our edge, and our edge is classified by this here, okay? This is going to be kind of the edge of our shape, kind of like the edge of our desk, the edge of the whiteboard here. Oh, you can't see it, edge of the whiteboard here. All right, there's an edge. It's not a face of it, but we know where it is, and that's kind of like the fold right there. Finally, then, again, up on top, this figure right in here is going to be our other base. Okay, so these are things that are going to be important. So now let's start defining some of these. So the first thing I want to define is what is a 3D figure. All right, a three-dimensional figure or a solid is a figure that does not, oops, I'll have to rewrite face in, lie in a plane. Now you're probably thinking, Miss B, what the heck does that mean? Well, remember when we were graphing lines, or y equals mx plus b, we had what we called a coordinate plane, and we would have a shape. You know, we could put like a square, we could put a triangle on it, but there was no dimension to it. It was flat because it lies within a plane. A 3D figure, like you see here where I drew these dotted lines, it gives it some dimension. There's more to it than just these flat shapes here. All right, so let's continue on. All right, so what is our face? Our face, not our face, like our face, is a flat surface shaped like a polygon. And a polygon is just a fancy word for a shape. Like a triangle is a three-sided polygon, a square is a four-sided polygon, a pentagon, you get the hint, is a five-sided polygon. So that's all you have to keep in mind there. So the face is a flat surface shaped like a polygon. So these are going to be our flat. If I were to isolate the face in my picture, it would just kind of look like a rectangle or a form of a parallelogram, okay, which are also four-sided polygons. All right, the next is our edge. All right, an edge is a segment formed by the intersection, like on the road, of two faces. All right, so when I said this was an edge right here, it's the intersection of where this face here crosses and then this one back here that I'm coloring black would cross each other. All right, we can't see all of it, but that's where they cross. So that is defined as then an edge. All right, so let's go back up to the top. I'm going to erase 3D. Let's now look at what is a prism. All right. So I said it's kind of like a 3D figure, but it's going to be a little different. Okay, it's a 3D, you can write three-dimensional if you want, but why bother? 3D figure with two parallel and, oops, man, I'm going off it, and congruent, parallel and congruent polygonal faces. What? All right, so it's a 3D figure with two parallel and congruent polygonal faces. So we have this face here in the front and then the one that's identical in the back. And so they're parallel to each other. So if I were to hold up, and let me grab my two rulers here, they're going to be parallel like this. All right, so if you look at my two rulers and I spread them out, they're going to be parallel to one another. They're the same size, they're both a foot, okay, and they are congruent, all right? Congruent just means, once again, the same size and shape, all right? So in order to make a 3D figure, you need to have the same size and shape. It's not going to work if they don't have at least two parallel and congruent faces. All right, so now I'm going to kind of erase this and we're going to go over again some more vocabulary. It's kind of a boring lesson, but we have to nail this down before we can move on. So the next one is the base of a prism, okay? The bases of prisms are the two parallel and congruent, two parallel and congruent polygonal faces. Okay, they're the two parallel and congruent. So again, this is how we can figure out what the base is. So for example, if I drew, let's go with a rectangular, this one's a little bit easier to understand. If I were to draw on the bases, oops, what you would see. Okay, this was my rectangular prism. The bases are going to be the bottom things right here. This one and then my top up here. They're two parallel. They're parallel to each other. They're never going to touch. And they're congruent polygonal. It won't work if they are not congruent. All right. The next thing is the height of the prism. And and like we said, this would be our height, all right? And the height is going to be the length of a perpendicular. Remember, perpendicular is when two line segments form a 90-degree angle segment that joins the bases. Okay, so if I'm looking at this right here, I know this is the height because look, here's my base 1, here's my base 2. This line segment right here forms a 90-degree angle and it connects my two bases together. All right, drop the marker. All right, and finally, we're getting there. I'm going to erase this so we don't get confused. We're going to talk about a cube. Now, if you've been in Miss B's class long enough, you know that I have a Rubik's Cube. And that's like a little fun shape I pull out every now and again to play with. But it's actually a very mathematical type of figure. And it's unique in some ways due to its sizing. Alright, there's my best, well, it's kind of my best cube. Alrighty. Alright, so that's as good as it gets. So a cube is a form of a prism. A cube, just like a square, falls under a rectangle, so it's a rectangular prism with, and now this is where it comes in handy, with faces that are all squares. All right, so that's the only unique thing about a cube. They're all going to be the same size, whereas the height was a little easier to pick out. So I could kind of flip this bad boy around like I would with the Rubik's Cube, and you could kind of say, oh, look, there's different things. Now, cylinder is kind of like an oatmeal container or a can of soda. You kind of think of it like that. Now, this is a cylinder. Now, we have to kind of take it and we have to look at it a little differently than maybe we would the figures that are just very clean cut. They have edges and stuff, okay? A cylinder, okay, and I'm just going to fill it in like it is on your notes. A cylinder has two congruent parallel bases that are, instead of squares or rectangles, they're circles. All right. So when I'm looking at my cylinder here, these are my bases, okay? But they're going to be in a circle shape, okay? So these are going to be my bases, all right? These two up here, and then this right here will be my height. All right. We're going to take a break. This is the end of video 1. You can continue on to video 2 to continue on with the notes.